Hello, Algebra 2. Here's your agenda for November. We're into November already. Today we're going to do notes 32 and you have homework number 33. So this lesson now we've gone over how we can identify how a graph moves because of A, H, and K. So if you didn't do the notes for number 31, you have to go back and do that first. So we've talked about how the graphs move. They move right and up or left and up or reflects over. And so today what we're going to do is we're going to look at graphs and we're going to write the function based on how the graph moved. So we're going to use A, H, and K, and what you're going to have to do is plug the number in for A, H, and K to write the function. So the essential question is, how do we write the function using A, H, and K for absolute value functions? And tonight's homework is at the end. It's a worksheet on writing the functions. And the homework appears at the end of this video, and I'll also upload it onto the Google Classroom Drive to view and print, okay? Along with this video. So when you do the homework tonight, you're writing the functions, so you don't have to copy the graphs. You're just looking at the graphs, okay? And I explain that on the slide at the end. All right, let's go. So if you can take a moment to write down the standard function for absolute value. I want you to write what's in the box right here. And this is for notes number 32. You do not have to copy the graph. Okay, and then I would like you to write this direction. Write the function equation. Write that down on your paper. Oops. Okay, so what we need to do is we need to identify if we have a number for A, H, and K. All right? So what that means is everything else stays put. So to answer the question right here, write the function equation. I want you to start writing with me. I want you to write y equals, and then I want you to put the absolute value bars, and I want you to put the x. Just like that. What we're going to do is I'm going to highlight, you just watch for a minute. We're going to decide what goes in these three positions. So if you look up to the top, we're deciding on A, H, and K. And that's all we have to do. All right? So we're going to fill in numbers, and this will be our answer right in this box. This will be our answer. Okay? We're writing the function. Now, before we get going, I want to show you something. So if you can pay attention, this is very important. Please pay attention. Watch the screen, please. Okay. Before we get going, I want to show you something on all of these graphs, so just pay attention. Here's the vertex dot. And if you notice, the very next dot, solid dot, ends up in a crosshair right here. And right here. The very next dot is up here, right, where it's in a crosshair. Now, if we make a movement here, it's just up one over one, up one over one. I want you to watch on the next one. If I make the vertex dot, the very next dot is just one box over. Same with this one, just one box over. I want you to watch on the next one. Here's the vertex. The very next dot is one box over, or to the left, one box over. I want you to watch on the next one. Here's the vertex, but the very next dot is not here. Oh, question mark. What happened there? What happened there? The very next dot is not to the very next box, is it? Where is the next dot? It's up here where the crosshairs, it goes through the solid crosshairs. So how much did this dot go up? It went up 1, 2 over 1. And same with this one. It went up 2, back 1. What about the next graph? Here's the vertex, and you're watching. The very next dot is not right here at the 1 box. Uh-oh, what does that mean? We have to count up until we find it. Here it is. How much did this go up? 1, 2, 3, and then it went over. 1, 2, 3, and then it went over. And if you kept going, 1, 2, 3, it goes and hits right here on the corner, right? And let me see if I have another one to show you. Okay, here's the vertex, and the very next box is not there. Where is it? 1, 2, 3. So it went up 1, 2, 3, and over. So when we're talking about it not being the next box, up 1 over 1, up 3 over 1, that's what we're dealing with A. That's how you figure out A, and A stretches it. Remember, it gets narrower. You can see how the graph is narrower. Same with this one. Even if it's upside down, it's not at the 1 box. It's 1, 2, 3. This one's 4. Okay? All right, so let's go back to where we were. Where were we? Okay, so each one of these dots is just up 1 box over. It's the very next box. Up 1 over 1. So that means the A is worth 1. It's a hidden 1. So we don't really need to write 1 in here because it's hidden. 1 times that is just that. If you want to write 1, I don't care. All right, now I'm going to erase these dots. We figured out the A. Now let's go ahead and look at where our normal dots would be from the lecture from Notes 31. Which way did this graph shift? It went to the right, 1, 2, 3. Each dot went 1, 2, 3. Each dot went 1, 2, 3. And really all you have to watch is the vertex right here. It went 1, 2, 3 to the right. Well, this moves it right or left. So which one is it? Which one did it move? If it went to the right 3, what kind of 3 do we need? If you look at your notes, we've talked about this being counterintuitive. It's a negative 3. So if we were to read this, negative 3 means take the opposite, which would be positive 3, and we move the graph to the right 3. So this one has to go in as negative 3, opposite of what you think. Now, is there any K movement? No. This graph would either go up or down, and there is no up or down, so we don't need a number here. And nobody really writes this hidden 1. So there's your equation. Now, if you looked at this equation, and I asked you which way does this graph move for negative 3, you should be saying right 3. And the graph did move to the right 3 from the parent function. It shifted to the right. Okay, let's go to the next one. Again, you're going to write y equals, because here's your answer, right? Absolute value bars. Put the x in. And we're deciding on the numbers in these 3 spots for A, H, and K. Okay, so here would be our normal dots for our parent function. So if you just watch the vertex, this big green dot, and match it up to this one, this graph moved left 2. So it went 1, 2 to the left, and then it went 1, 2, 3 up 3. So how do we take left 2, up 3 into our formula? So A is just 1. And we know that because of what I said at the beginning of this lecture, It's just moving by one box, right? It's only one box over. There's no stretching here. Okay, so we need to add left 2. So left 2, and we need to go up 3. Now the up 3 is easy because that means we just go plus 3 in the back because K moves it up or down. We don't really need this hidden 1. And what do we write for left 2? We do opposite of what we think. We put plus 2. And there's our answer. Now, if you stop and think about it, if you looked at this from what we did on notes 31, would this move left 2, up 3? It sure would. Remember when we did that on Thursday and Friday last week? And then you don't really need to fill in the hidden 1. Okay, let's go to the next one. Okay, so here's our parent dots. And we're watching the vertex. That's the easiest. So you're going to write in your box y equals, put the absolute value bars with an X. And we're going to figure out these 3 numbers again. So in these 3 spots. Okay, so each dot moves just one box. So this again is 1. This time the vertex moved 1, 2, 3 to the right. The graph went this way. And then it also went up. And it went 3 right, up 1. So we need 3 to the right, and then up 1. So again, the number in the back's the easiest because it's not opposite, it's not counterintuitive. Up 1 means plus 1. The number in the front's easy because that's just a hidden 1. And then this one, 3 to the right. So do I put the number plus 3 or minus 3? Whoops. You put minus 3. 3 to the right is a minus 3. So if you looked at this, you would say negative 3 means really in my head positive 3, and positive goes to the right. So this is right 3, and this would be up 1. All right, we're going to move on to the next one. Now, this one's different. You can tell normally the dots would be one box over, but this one is more than one box over. So our A is going to be different. Okay, so let me put the parent dots on. So this one is moving to the left, and then it's moving up. So let's figure these 3 numbers out. So we need to write the function. That's going to be our answer. Okay, so since this didn't go up one box over one box, remember how we talked about that? That's the A value. It went up 2 boxes and over before it hit the graph. It went up 2 boxes, so up 2 over 1. And you can see the other way it goes up 2, back 1, right? So that means our A is going to be a value of 2, and you can tell your graph is a little bit narrower, because if not, it would be out here. It's narrower. Okay, what happened with our H? So it went to the left, 1, 2, 3. So left 3, and it also went up 1, 2. So our up 2 is easy, it's right here. Our 2 in the front for A is right there. And now just be careful, left 3 You go in opposite, so it should be plus 3. So this is a stretch by 2. This is a left 3, and this is an up 2. Our final answer is what we're putting in our box. This is our final answer when it says write the function equation. So this is what you're going to be doing on your homework, is just writing this kind of function equation, okay? You can hit pause if you need to. Okay, here's another one. So I need a pen. There we go. Y equals absolute value with an x. Write the function equation. So we're deciding on A, H, and K. We're going to fill those in right here, here, and here. Okay, so here's our parent function. So 0, 0, and then 1, 1, just one box over. So let's start with A. So does this go one box and over? Nope. It went up 1, 2, 3 boxes and over. So this one's going to be 3. And if you wanted to double check yourself, you could count the other way, 1, 2, 3, and over until you hit the graph. So A is worth 3, and it stretched it. And then the graph moved over 4 spots. So it moved right 4. And then did it go up? Nope. The vertex is still on the x-axis. So K is 0. We don't need a K. So there's no movement on K. No up or down. There's no up or down movement. We need the 3 in the front here. Stretched by 3. And then moving to the right means negative 4. And we're done. You can hit pause. Okay, y equals absolute value bars with an x. I'm going to fill in those numbers again. So A, H, and K. Okay, here's our parent function. 0, 0, 1, 1, negative 1, 1. So let's check. Did it go up one box over one? So from the vertex, did it go up 1 over 1? Nope, it's not there. The graph's not there, so we got to count how many it went up. 1, 2, 3 over 1. 1, 2, 3 back 1. So this A is going to be 3. This graph again moved to the right. 1, 2, 3, 4. So right 4. And then it also moved up. 1, 2, up 2. Okay, so we just have to fill in the numbers. So a 3 here. What do we put for right 4? Negative 4. And up 2 plus 2 is on the outside. You can hit pause here. Okay, what's going to happen for reflection when it opens down? So we're going to fill in A, H, and K. We're going to write the function. And we're going to fill in those 3 spots. Okay, so what do we do for a reflection? What do we do for reflection? We put a negative sign. So whatever A is, we have to have a negative sign. So Normally our dots are like this, but they reflected down, and the dots are below, so that means we need a negative. Now, did these dots go over 1? No, they're not there. So they went 1, 2, 3, 4 over. 1, 2, 3, 4 and over. So we need a -4 for our A. Now, did it shift to the right? Yes, it did. It went right 1. And then did it shift down? Nope, there's no shift down. We know that because this is still on the x-axis. If it did get shifted up or down, your graph would be like up here and go like that, right? That would be a shift, up or down. Okay, so no up or down. We know that because the vertex is still on the x-axis. Okay, so this will be a -4. There's nothing on the outside, and your h will be right 1 would be -1. And there's our final answer. So the -4 reflects it, and it went to the right 1. Okay, so here's your homework, number 33. So there are multiple slides. Keep watching this video for all 12 problems. For this homework assignment, you do not have to copy all the graphs. The graphs are to look at. So you have to write the absolute value function using this, right? So you might want to write that on your paper. And then number a piece of paper, just like this is down here. So homework number 33, you're just going to have, you're just going to have 1 through 12 with a bunch of equations, okay? So when you write your homework paper, you just have to have homework 33, and then all 12 answers have to be as an equation. Fill in A, H, and K. All right? Fill in A, H, and K for this homework. Okay, I'm going to advance the slides so that if you want to stay on this video and do the homework. So this is number 1, 2, 3, and 4. And you can hit pause here while you do number 1, 2, 3, and 4. Remember, you're writing an equation for each one of these, right? So the answer for number 1 should start y equals, and fill it in now. Absolute value, and then fill it in. What are you filling in here, here, and here? Just like we did. Okay? You can hit pause if you want to stay on the video. Here's number 5, 6, 7, and 8. Be careful, I numbered these down. Make sure you're watching which one's which, so we don't get the answers wrong, okay? You can hit pause here. And then here's number 9, 10, 11, and 12. And you can hit pause here if you'd like. And then also, this is available on the same assignment on Google Classroom as a file if you just want to pull that up and take a look at these graphs there. Otherwise, thank you very much, and that's the end of today.